Firstly, thank you so much for having me here. It's always delightful to be talking to local young minds. Without much further ado, I'll quickly introduce the TRIBE cluster to you. So TRIBE stands for Delhi Research, Implementation and Innovation. It's an initiative of the Principal Scientific Advisor to the Government of India on the recommendation of the Prime Minister's Science and Technology Advisory Council. The logo there is for TRIBE. Now, what is TRIBE? So TRIBE basically is the Science and Technology cluster, which is supposed to bring together industry, academia, and government bodies to take innovations from lab to market. So basically, it's a platform bringing together all the stakeholders that can work on taking innovations through various stages and scaling them up and bringing them to the end user. Now, the concept of these clusters may be new to India, but it is very, very well established in the West and has been working very well. One of the biggest examples of such a cluster is Silicon Valley. But there are smaller clusters that exist both across Europe and other parts of the US. And that's exactly what we want to bring to India as well. India aspires to be a $5 trillion economy in a few years. And not only that, particularly with the G20 presidency, it has to do it in a sustainable manner, which takes care of the environment. Therefore, the objective of our cluster is to leverage science and technology to bring about this balanced growth, economic development, but on the pillars of sustainability. Therefore, our focused thematic areas where we work on are all aligned with national missions and UN SDGs, like waste to wealth, water security, air pollution, green energy, AI/ML in healthcare, e-mobility, public transport, and effective education. Now, reason why I'm telling you all this is, although there's a link to AI and ML in healthcare, but like the previous speakers were talking to you, we have to see things in a more holistic manner, in a more integrated manner. Unless we take a multidisciplinary approach, and unless we first look at the context and then operate, we would not be able to create fruitful solutions. Now, there are 100 plus members of TRIBE as of now. We started with a cluster of purely academic institutes. TRIBE is headquartered at IIT Delhi. Triple IIT Delhi is one of the main members of the cluster. Other members are organizations like AIMS, government CSIR, laboratories, and some private institutions as well. We are bringing now more and more corporates into the picture, NGOs, startups, MSMEs, anybody and everybody who can play a role in taking innovations from lab to market. Few successful examples of the innovations that have come out of this cluster, and this cluster has been operational for just over 1.5 years, almost 2 years, but still we have had some very early wins, and I'm very glad to share that some of the most shining examples that have come out of the cluster are from your institute. So firstly, Professor Sethi's work that Professor Bose was also mentioning earlier, as part of the TRIBE initiative, has been early detection of COVID, which can be extended to any other infectious diseases. So we have developed an NDHM compliant platform on top of which various models can be built, AI/ML models can be built, that can predict any spike, genomic sequencing, any spike in the change, and that can be done up to 2 months in advance. So that gives enough lead time to policymakers to take action, any remedial action that needs to be taken, as we learned from COVID. And this does not only apply to COVID, it can be extended to any other infectious diseases before they turn into pandemics. Another example, which is not related to healthcare, but is AI/ML driven, that comes from your institute, was was done by Professor Pravesh Puyani in the area of public mobility. And they digitized the public transport system, created an app for managing the bus system and the depot system in Delhi. It has been successfully adopted by the Delhi government. All the buses in Delhi are now on that system. So that gives a live tracking, and that goes to the depot managers on the one hand. On the other, it makes public transport much easier and accessible to the public. They can track live location of the buses and get a right name. So these are, couple of shining examples coming from your own institute as part of the cluster initiative. Other areas where we're successfully working on, for example, e-mobility. So the cluster is working on developing charging infrastructure. So as you all know, one of the missions of the government is to mainstream e-mobility so that there's less reliance on petrol and diesel vehicles. In order to do that, there are a number of challenges. One is the lack of charging infrastructure. So the cluster is working on developing low-cost, portable charging infrastructure so that it can be scaled up across the nation. Also, another innovation that's happening is as long as the charging infrastructure draws power from the grid, it's not really green because ultimately the electricity that you're consuming is produced by coal. So unless we tap into more sustainable form of energy, it won't work. So they're working on integrating solar panels with the charging infra, and also developing battery packs. So right now the challenge is on the cost front of, on the front of the battery pack. We're trying to reduce the cost down and make the system more efficient and compact, so that the entire primary source of energy can be utilized as a solar energy. The other examples are in the area of waste management. You see, in Delhi NCR, you see heaps of landfill sites, and they ultimately are a source of pollution, of diseases, of so many other types of nuisance. So there are technologies, particularly plasma pyrolysis technologies that can bring down the level of waste, reduce them, and not only kind of pyrolyze and convert into gases, but then those gases can be captured and harnessed and converted into hydrogen, bottled and converted into hydrogen. And that again kind of leads to a circular economy and waste to wealth. And that hydrogen is another source of green energy for so many use cases. There are multiple other examples that I can go on and on about, but in the interest of time, I won't say much. The other thing that I would like to mention is in terms of the challenges that are there in scaling up initiatives. So here I was talking about some examples that have been so successful. But in general, you would have seen over the past decade, our country has developed a phenomenal ecosystem in terms of startups, but startups that are based on currently digitizing or creating digital platforms. There is no kind of infra that's ready out there in supporting for R&D related, science-based development. And that's what Drive is trying to create. So two challenges that are there is in terms of creating piloting opportunities. So a lot of R&D work gets done, but beyond the lab stage, it doesn't see the light of the day. Why? Because there are no test beds. There are no sandboxes that are easily available. So what the cluster is trying to do, it's trying to look at the ultimate users, be it from corporates, be it from public bodies, who would have a vested interest in taking those solutions to the market, bringing them in the fold, getting their early buy-in, letting them allow piloting opportunities with their organizations, with their institutes, and then adopting those technologies. Particularly in the healthcare sector, we've been partnering with funds like India Health Fund. Then we have corporate-backed accelerators working with us on healthcare as one of the thematic areas, plus all the other thematic areas that Drive works in. We are partnering with hospitals. We have signed an MOU with GMDA, Gurgaon Metropolitan Development Authority, where the entire healthcare infrastructure can be available and accessible to people who want to test. We have partnered likewise with MCG along the same lines, Haryana Pollution Control Board, and we are also trying to bring in more and more corporations that work on sustainability on the CSR side, right? So there are a number of large funds available within the CSR framework that are actually, some of them end up being a welfare activity, but some of them are doing a lot of work on the ground in terms of, especially in the rural healthcare sector. So we are partnering with those, for example, HCL Foundation, Shivnada Foundation, that are actually villages and taking innovations to those villages and providing them with healthcare services, and then that's where the scale up happens and those models can be rolled out. So all these things are available to you under the Drive umbrella. Very recently, just day before yesterday, we hosted our first annual flagship conference, Resolve. It was inaugurated by the Principal Scientific Advisor, Professor Sood, virtually. On the stage that day, former PSA Professor Vijay Raghavan was there who delivered a keynote. The Swedish DG, who's I think the Swedish delegation is visiting you now as we speak. DG Purana was there, delivered a keynote. And then a number of industry people and a number of government bodies were there to participate, and we showcased all the initiatives that Drive had delivered in the span of 18 months, or the past 18 months. Now, what I am looking from you is, because this is an annual conference, right? So the same conference will happen next year in December 2023. Instead of just 2 innovations that we showcase there from Triple IIT Delhi, I want at least 50 innovations that we can be proud of and showcase to the Principal Scientific Advisor, to the government of India. So with that, I take a pause here. In case there are any questions, you can ask. Otherwise,
Thank you, ma'am, for a wonderful insight on collaboration of health and tech. Request you to stay on the stage, and I would request Dr. Gitanjali Yadav, ma'am. She is a scientist in NIPGR New Delhi, to felicitate, ma'am.
The energy in the room has definitely doubled, Shikha, ma'am. Definitely.
we are teachers and trainers, and I think what is important is that our guests.
Thank you so much, ma'am.
We are on track together, so that's a special pleasure to meet you. Thank you.
Thank you so much, Shikha, ma'am. Proceeding further, I would like to invite Mr. Utkarsh Uppal, NVDI representative, to share his thoughts on digital health, case studies and research. The Deep Learning Solutions Architect. Over to you, sir. Are we all ready to listen to him?
I know you had your lunch just now. I'm Utkarsh. I work as a applied deep learning solutions architect at NVIDIA. Primarily, 5 years back, I was standing on this stage itself, as an IEEE representative. There was some congress we used to have as part of the Delhi section. And it's great, we have been collaborating a lot, specifically with Dr. Tubbs group, because in India, what I'm going to present to you guys, I won't take that much of your time because what I feel is you guys basically need to understand what's happening globally, and what I'll show you is from a NVIDIA standpoint, because I come from a research background myself, but I'm in industry currently as a deep learning solutions architect. So my background is I work on LLMs a lot, primarily both from a healthcare section also and from a generic Indic languages also, right? But what I want to show you and capture your attention is what is actually happening entirely in terms of around the globe, and where we are, what I feel. I tell them everything. Okay. So how many of you know LLMs? Hands up. Yeah. Ma'am, what is LLM? Do we have the mic for the audience? Large language models. Okay. What is large language model?
So basically, models like birds, which are like trained on very high amount of data. These are data hungry models.
Okay, these are data hungry models. Cool. So, most of you, you might somewhat, worked on medical imaging, right? How many of you have worked on medical imaging? Sir has worked. Okay. So those who are not aware what medical imaging is, basically, currently, out of the entire healthcare data we have, about 90% of the data, it's imaging data. When I say imaging, it's, primarily your pathology, radiology, these kind of data sets. And primarily, when you talk about AI, which is, a key driver of our generation, all of the research is primarily focused around medical imaging from a healthcare standpoint. Because ultimately, 90% of the data is contributing to that sector, right? But if we take the bigger picture, so when I say the bigger picture, what I mean by that is basically, there is a healthcare as a vertical, there is finance, there is retail, there are other verticals also. Can anyone guess which vertical generates the most amount of data? Any wild races? Anyone? Sorry? Fintech, okay. Anyone at the back? Sorry, aerospace, okay. Anyone else? Laboratory imaging, okay. So currently healthcare only generates the entire, or you can say majority of the data. When I say majority, is quite close in terms of with fintech. So 1/3 of the data we generate every day is of healthcare. And what we believe as industry leaders, that this data from 1/3, which is basically 33 odd percent, it will going to change in upcoming 3 odd years to 40 odd percent. And what is the factor which is contributing to change or generation of this data from 33% to 40%? The sole factor of that is we are only focusing on imaging right now, right? From a healthcare standpoint also. We as a country, we have transitioned very well when we talk about from an AI standpoint for a healthcare domain, right? 5 years back, we started with Clara. Clara is our SDK, which is for healthcare. But the contribution of that 10 to 15%, which is going to come, it's from a life sciences domain as well, right? So it is healthcare and life sciences. Hence, our CEO Jensen Huang, he believes that the field of digital biology, along with the medical imaging, so it's two fields in tandem. So when I say digital biology, the models, the large language models, they are going to be a huge push, and this thing or this picture is going to change very rapidly. Hence, as we have transitioned from basic AI or basic machine learning based algorithms to your complex deep learning based medical imaging applications, including self-supervised learning, federated learning, those kind of words. And I'll come what those words are basically. The same thing is eventually going to happen for drug discovery. Because what is happening in genomics is the cost of generating the sequence, it has now decreased considerably. Right? Hence, we are generating a lot of sequences, but analyzing those sequences need a lot of compute. Right? And the algorithms, because for example, let's suppose I am doing a genome sequence analysis, so there are millions of iterations you need to run in terms of, hey, whether the sequence is matching with this or not, and what is the nucleotide variant from the previous one. Right? So there are millions of iterations which are needed. And the trivial simulation-based algorithms, they are primarily CPU driven. Data is a lot of generated, but the algorithms are still old. They are transitioning eventually. So there are key domains. So when I look at this slide, you can see, we have written FLAIR is one of them. FLAIR is for federated learning. Now what is federated learning? Anyone has heard this term before? So
basically, you don't want to centrally store the data because of data protection and privacy. And in that kind of scenario, you want model to come and be trained on data instead of data being shared, especially in hospitals. They don't want to share the data.
yeah, exactly right. So federated learning, it's a general term, right? This paradigm is not for healthcare specifically, right? The term is basically, okay, how many of you have trained the AI model before, irrespective of the field? Raise your hands, like, I cannot see at the back. Okay, a few of you have trained a model, AI model before. Cool. So for AI model, if you want to train an AI model, few things are essential. First is you need your data, you need your model or algorithm in more simpler terms, and you need a hardware underlying for that, right? But what happens is, specifically in certain domains or segments, including healthcare, you cannot, expose the data as it is to the algorithm which you are trying to train. Because if anyone asks me, because I see most of you have not trained the AI model, so I'll again backtrack a bit and I'll explain you, what AI is in one line. Right? So what AI is, whenever anyone asks me, it's a simple y equal to fx. Right? It's a function approximation where we have y, we have x, we just need to find the function. That's it. The entire AI is built on this function approximation. We just need to figure out the black box. So what happens is, in federated learning based approach or in generic approach, we have that entire set of data sitting somewhere, right? We cannot expose it as it is in certain domains like healthcare, finance, right, defense. These kind of domains, what we need to do, we segregate the data identity and we build a sort of server-client architecture, right? It helps us to mask the identity of the data and we can train the black box accordingly. This is federated learning. Most of the medical centers, hospitals, research institutes, specifically in healthcare, this is the technique which is going to be a sort of base. The algorithm or the black box will remain the same. Your approach of getting that black box trained or monitored is going to change. That's federated learning. The second is MONAI. So MONAI is basically, what we did. So our CEO again, Jensen, he's a very developer-friendly mindset. He comes from a sort of tech background himself. So what we did, we along with King's College London, we started an open initiative, which we call MONAI. Now it's visible at the, okay, great. So FLAIR we already talked about. FLAIR is your NV FLAIR or federated learning. Then we have MONAI. So I already told you why we need FLAIR or why we need to use federated learning down the line. Now backtracking a bit again, why we need MONAI. is basically you cannot use your algorithms. For example, I am training a model or I am training my black box to segment or to detect my face or people's faces, right? I cannot use that same model or architecture for training on medical data set, right? Hence what we did, understanding that your medical algorithms and data, it's in different formats. You can have a DICOM image or you can have different modalities in terms of CT scan, ultrasound, MRI, right? What we did, we created a framework, right? So there is PyTorch, there is TensorFlow, which are very basic and very commonly used, right? So those who work or train AI model, you might have heard about these frameworks. Monai is again the same thing, built on top of PyTorch or a basic deep learning framework, but personalized for your medical imaging applications, right? So whenever you want to train a model, let's say brain tumor segmentation, spleen segmentation, your radiology and pathology based application, journal, surgical robotics, the 90% of the so-called data I already talked about, Monai is the place to start with, right? And currently, we proudly as an organization, because since this is an open initiative, so we have more than 50, contributors in terms of Monai as an open initiative. Because we have Clara also. We used to have Clara imaging, and now Monai is an open initiative. So anyone can go on Google and search Monai, and you'll get all the codes and GitHubs for training a basic model. The next thing is basically your HoloScan. So what I'm trying to do is I'm trying to cover different domains of healthcare, because what's happening is, I already talked about drug discovery, I already talked about your large language models for genomics. There is one such segment which always lags behind, because when we discuss from a research standpoint, folks only talk about either drug discovery or imaging, right? Another thing is you're accelerating the devices in your hospitals, right? Or so-called smart hospitals, as we say, right? So third thing which is there is HoloScan, right? So your entire pipeline, I'll show you a few demos what we have done in different hospitals globally, right? What you can do is a robotic surgery based, application which is deployed in a hospital. You can accelerate that application, or you can use the HoloScan stack for building that application from a ground up, right? So there are 5 pillars on this, and you can see at the bottom there are 2 things. One is your AI, and second is your Omniverse. Anyone has heard of word Omniverse? Okay, sir has heard it. Anyone else? Metaverse. Anyone has heard Metaverse? Ma'am, what is Metaverse? Okay, you have just heard about it. Okay, cool. So Metaverse is so-called what we call Web 3.0, or a kind of, a realistic or a virtual kind of environment we will create, right? Or it's a concept, right? A 3D collaborative environment of sorts. Now, what Omniverse is, it's the stack you need to go inside Metaverse, right? Because Metaverse is a concept. You need applications which can help you, go to that concept. I'll show you a very interesting demo today, where what we are doing is we have created a digital twin of your surgical and your medical center, right? So all the like students or surgeons who practice, what they can do is they can practice inside a digital twin, right? So it's both AI is also going on, and your upcoming technology, which is your metaverse based technology, it's also going on hand in hand. Any questions, anyone? Yes sir, go ahead.
Thank you, sir. Sir, there is a question that we all are actually from healthcare sector background, and all these are happening from all those technology field. we only know how to deal with the patient and how to deal with the doctor. So how these are going to benefit us? I mean, all those people, I mean, there are lots of people who are getting jobs in this sector only because they have lots of knowledge regarding coding, etc. I mean, they are from computer science background. Even in healthcare sector, they are occupying all those spaces. So how this is going to benefit us, and how can we actually find opportunities for such things?
So,
Thank you.
this is a very tricky question of sorts in the sense. I'll take this question in two parts in the sense. First is how you can, get into this first part. Second is how, you can transition or folks who know coding. For example, so my background is, I am from a robotics and AI background, but the research which I did was in healthcare, right? So I am not a, kind of hard code based healthcare based background, because my bachelor's it's in computer science and electrical, right? But the objective of AI is not to remove you as a healthcare based pick. You are SME in your domain. I am SME in my domain, right? SME is subject matter expert. AI is only needed, or you are going to leverage AI, right, as an assistive based tool, right? When I say assistive based tool, so let's take an example, like I'll answer this question from again a stack point of view. The first thing you can see on the screen is label, right? Label is written there. So I am not from a healthcare background, right? So I cannot label a CT scan or MRI which a radiologist or a clinician can do, correct? What I can do is, you need to label your thousands of images or thousands of CT scans so that you can basically subsequently either train a model or do that job manually. Am I right? What I need to do is, I need to get a label data from you. You are doing your annotation redundantly, and I cannot identify what is MRI, what is tumor, or what is hematoma, or whatever, right? Now what you can do is, you can label a few CT scans, right? And either you can train yourself if you are capable in terms of you believe that you can train an AI model, or then where this deep learning based, or the folks who you are saying that they know coding, they can train the model and they can give you the model back. What you can do is, now you have a model which you can leverage for segmenting your brain tumor, right? Now your job, it's bit decreased in the sense, some decisions. So for example, I have a MRI again, a customer or a patient comes to me as such. What you are going to do is, you are going to use my black box, and you are going to have the output CT scan or MRI which is segmented, right? Now your job becomes easier in terms of the annotation is in front of you. You can just check whether it looks good or not, and what are the areas which are a bit bad in terms of predictions, and that's it. So the time for diagnosis or prognosy, or whatever plan we want to make in terms of evaluation, that gets decreased because of such kind of models, right? Does that answer your question? And if you want to start, that's a really good thing in the sense, now instead of 2 persons, we only need 1, right? For example, you can only, you have expertise in both healthcare and deep learning, so you can train your model, and you can only also identify. That's the best thing which can happen. Anyone? Yes, ma'am.
Can you talk more about how metaverse can benefit healthcare users like iPhone?
Yeah, I'll come to that. So what we have done is, I gave you an example of training from a labeling perspective also. All the, commonly used tools like, for example, for radiology we have your 3D slicer is one of the tool, Pair is one of the tool, right? We have CVAD for video-based annotation. What we have done is, we have leveraged a so-called AI-based technique which is known as active learning, right? Like federated learning is one, active learning is another one, in which what you need to do is you need to just manually view parts and the rest of the thing will happen automatically. Those algorithm or those capabilities of Monai, which is Monai label, it's integrated already as part of these tools, which are already there, right? So I have a small video on Monai before we move to the next segment of HoloScan.
In surgery in general, and neurosurgery specifically, you can fix what you can see. Therefore, visualization is critical in our life.
If you're able to interact and visualize that patient's images, you are better able to plan the correct intervention and make sure that you apply the right intervention the first time.
The way to see Monai as a toolkit which is dedicated to AI in imaging.
So Monai is a community-driven effort to bring data science into the clinic. And that's everything from the development of data-driven products and the curation of data to then how we get those insights in front of clinicians looking after patients.
Since adopting the Monai infrastructure, it's freed us to focus on application to specific clinical problems and catalyze that application in multiple directions.
What we can do through Monai is that be able to segment the tumor, segment all the critical structures around it, and in surgery provide real feedback data to navigate the surgeon around the tumor to make sure most of the tumor is removed. Therefore, we're providing the patient with the most benefit.
What Monai then brings is the final layer on top, which is a way to scalably apply artificial intelligence across that entire medical record, across every patient pathway. The potential scale of that is massive. I can see Monai in every clinic, in every hospital across the world.
Anyone? Yes, sir.
Yeah, I can say about Monai and Metaverse. I'm doing a pilot on something very similar to what you mentioned. Using these monoscans, creating an artificial robo of me. I am a doctor. Then creating my clone of Dr. Amit and giving that patient an experience. For example, I am a cardiologist and I'm using this dynamic roadmap for my cardiology cath labs. Like companies like Philips and GE, they come up with certain roadmaps, like a navigation tool, just like the Google Maps. We navigate these, get inside the heart. So the brain, and more focused on cardiology. So in surgery, what happens is we create a 3D model and also the robo of me to operate and how we see the outcome of that, how the patient. So that it's all patient information. That how he sees his heart getting operated by the surgeon whom he is visualizing in the Web3 metaverse form. Yeah. And colleague had asked that beautiful question of healthcare getting into this. It's a huge opportunity. US, Mount Sinai, many hospitals are adopting it, and we've been working with them on information exchange. We see a huge game changer. This is switching this meta web.
Okay. So next is HoloScan. So sir was talking about from a metaverse standpoint what we can do. Again, what we have done is Okay. So HoloScan is basically, but primarily we have built this with only one objective in mind, which is accelerating or increasing the accelerating capacity of the medical devices, right? For example, you can see in this case study, we did. So the pipeline includes, first is your input image or your input video frame, which you'll directly get, right? And a segmentation model which is running, right? Primarily, what is running, it's basically, detecting the device, I should not say the devices, but the instruments which are being leveraged for surgery, right? And what you can do is, or what's happening in real time is, that is overlaying on top of the input feed, right? And the entire thing, it can be, analyzed parallelly what is happening. This has application in both robotic-based and human-assisted surgery which you are doing, right? And what we do is, right from the bottom layer, from a hardware perspective also, and from a lower level libraries. Because what we did with this hospital in US is, the frames per second, it was only 6 frames per second which was coming, right? And it's very bad. Those who know, do not know like how bad 6 frames per second is. It's like, me having a video and watching after some certain seconds. And it created a huge negative impact in terms of from a surgical perspective, right? So from both your AI algorithms based and the medical devices which they are, what we did, we basically accelerated the stack at the bottom layer or the application layer, right? So there is something called as CUDA. So whenever you want to use any compute in the backend, you need to talk to that compute through CUDA, right, or GPU in particular. And what we did, we increased the frames per second from 6 to 60. And parallelly, when we basically mapped this into a digital twin, right? So those who do not know what digital twin is it's basically your avatar, right? Either you can create a digital avatars or you can create a twin of your entire scene which you have, right? So in the upcoming slides, I'll show you, how we created a digital twin, again as another use case which was needed, and it helps all the students and the researchers, and the upcoming surgeons to practice in a digital format rather than like in a real before that.
Digital twins created in NVIDIA Omniverse can model physically accurate hospital environments, operating rooms, medical instruments, and even a patient's individual anatomy. Medical device developers can use these digital twins to create AI-enabled solutions. One use case is neurosurgery. During a procedure, a surgeon needs to manually reposition a robotic microscope to maintain focus on the region of interest and align it with their instruments. This prolongs the surgery and increases a patient's time under anesthesia. Let's see how this can be improved with an AI-based solution using a digital twin. We start with an NVIDIA IGX computer running the Clara HoloScan SDK, which includes a pre-trained tool segmentation model. Real-time inferencing performance is validated with virtual scenes from Omniverse. In deployment, the IGX platform has been optimized for AI processing and visualization of high-bandwidth data streams. For example, 4K 60 FPS video is processed in less than 15 milliseconds. Without AI tracking, the microscope will not maintain alignment with the surgeon's tools. With tracking, the IGX platform automatically tracks the position of the surgical instruments and controls the real-time movements of the microscope. This can reduce the patient's time in the OR and improve surgical efficiency. The IGX platform is optimized
So there was one doubt on metaverse. I hope that's answered in terms of the application. Okay. So to wrap up my session, I want to quickly cover from a drug discovery point of view. So a few years back, transformer-based models. So from an AI perspective, they basically, started a lot, right? So what happened was sequences or your proteins, they can also be, analyzed using so-called large language models, right? Hence, what was done is models like AlphaFold, which is again your large language model, to predict your protein structure, right? These types of models, they started, being proposed in the healthcare domain. And the same thing, now since I already talked about your 10% of the data from a drug discovery, to explore the domain of drug discovery, that's BioNeMo. And recently, we collaborated and we've started an initiative with Broad Institute, like it's basically a leading healthcare genomics institute in the US, with MIT and Harvard, where we are going to expand the capabilities of this genome-based models in the upcoming few years. So to end my session, I have one small video which will capture entire applications irrespective of whether it's AI in healthcare or whether it's AI in drug discovery.
Bringing clarity to our most important questions.
Diabetic retinopathy can happen if blood sugar stays too high over a long period of time.
And comfort in times of uncertainty.
What procedure am I having today?
You are having a bronchoscopy. Shining a light on a path forward.
You gotta get an OR.
And finding answers when every second counts. I am watching over our frontline heroes, creating a safer place to do their life-saving work, guiding them to faster answers. And delivering care wherever it's needed. I am opening new worlds of discovery and mapping new treatments for every individual. Creating a community to collaborate with thousands. Sharing knowledge that can heal millions. I am AI, brought to life by NVIDIA and brilliant healers everywhere.
Thank you, everyone.
For a moment, and I would request Dr. Vijay Singh sir to participate. Sir, please. Please give a loud round of applause for such an insightful session. And it was an eye-opener for us as a doctor and clinicians, as well as for people from tech background as well. Small question.